Hello everyone, in this video we are going to see the Leetcode question number 35, search insert position. The question is, given a sorted array of distinct integers and target values, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm in O of log n runtime complexity. We are given few examples here. In the first example, the nums list is 1, 3, 5 and 6 and our target value is 5. We have 5 in our list which is in the second index. Python index starts from 0, so that is 0, 1, 2. So our output is 2. In the second example, the nums list is 1, 3, 5, 6. And the target value is 2. We don't have 2 in our list. So if it is inserted, it will be inserted in the first position. So our first index is 0 and our second index will be 1. So we are returning the output 1. In the third example, our list is 1, 3, 5 and 6. And our target value is 7. We don't have 7 in our list. If it is inserted, it will be inserted in the fourth index position, which is after 6. So we are returning the output 4. I hope the question is clear. Now let's see the approach how we can solve this problem. Let's see an example where our nums list is 1, 3, 5, 6 and our target value is 5. We have 5 in our list. Here is the index position of our list. First, let's assign a left pointer and the right pointer to the list. We are assigning left pointer to the 0th index and we are assigning the R pointer to the last index. In our case, we are assigning the R pointer to the index position 3. We will repeat these steps until left pointer is less than R pointer. Once left pointer is greater than the right pointer, we will break the loop. Now, we will find out the middle position. Our middle position is left index plus right index divided by 2. I am having mod in order to eliminate the decimals in the result. We will assign middle pointer to the index position 1. Now we will check the middle element with the target element. In our case, the middle element, which is 3, is less than 5. Since the middle element is less than the target, our target element cannot be before the middle element. We are incrementing the left pointer before the middle element. Now we are repeating the same steps again. We are finding the middle element again. Now our middle element is 2 plus 3 divided by 2, which is 2. We are shifting the middle pointer to the index position 2. In this case, the middle is equal to the target, so we are returning the element of the middle pointer, which is 5. Let's take another example. In this case, the list is 1, 3, 5, 6 and our target element is 2. In this scenario, the target is not in the list. First, let's assign the index positions and we will assign the left pointer and the right pointer. We will find the middle position. Our middle pointer is 0 plus 3 divided by 2, which is 1. We are assigning the middle pointer to the index position 1. Now let's compare the middle pointer with the target. In our case, the middle pointer element is greater than the target, which is 3 greater than 2. So our target element cannot be after m. In this case, we are shifting the R pointer before m, which is R is equal to m minus 1. Now we will repeat the same steps. Now we will find the middle pointer. Middle pointer is 0 plus 0 divided by 2, which is 0. Now we will shift the middle pointer to the index position 0. Now target is greater than middle pointer. Since the target is greater than the middle pointer, we are shifting the R position after the middle pointer, which is L is equal to m plus 1. Now we see that L is greater than R. So we will break the loop and return L, which is index position 1. I hope the approach is clear. Now let's get into the implementation. First let's assign the left pointer and the right pointer. Our left pointer is 0 and our right pointer is length of nums minus 1, which is the last index position. We will do the binary search until the left pointer is less than or equal to the right pointer. While left less than or equal to right, we will find the middle position, middle equal to left plus right divided by 2. If the target is equal to the middle element, we can immediately return the middle index position. If target equals to nums of middle, return middle. If target is greater than the middle element, we will shift the left pointer to middle plus 1. If target greater than nums of middle, left pointer equals to middle plus 1. If the target is less than the middle element, we will shift the R pointer before the middle element. Let's do that. Else R equals to middle minus 1. At the end, we will return the left pointer. Return L. That's pretty much it. Now let's submit it. Our solution got accepted. Here is the complete code. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I will see you in yet another interesting Leetcode interview question. Thank you.